Hello, it's Keith here, and this is lesson 15 of the Suck Hunt series, in which we look at parts of the code of the Suck Hunt game. Now, today we're looking at Spectrum Next. This is part 3, the final part of this Spectrum Next code. So we're going to be looking at the title screen routine and the main game loop, and we'll also very briefly discuss the control routines. I'm not going to go into them in too much detail because they're based on stuff I've covered in the platform-specific series: keyboard reading, Kempson joystick reading, and also mouse reading. Basically, the game can either use a Kempson joystick, a Kempson mouse, or it can use the cursor joystick. Those are the three options it supports. Let's go over to the source code and let's take a look at what we've got today. So here's the start of the routines we're going to be looking at. You'll notice we're loading BC with 4000 here. This is a delay loop. Basically, the title screen will show for a while and then it will eventually show the introduction again. So that's just a delay there to do that. Now what we've got here is some routines that are relating to handling different kinds of key press. So the first one we've got here is toggling the key mode between the three different key input options, so the cursor keys and the Kempson joystick and the Kempson mouse. So basically we're just toggling it here and showing the key mode on the screen. You can see here it says Chem for Kempson. There wasn't really space allocated in the screen to show the text, so I've just kind of hidden it down there just out of the way to stop from spoiling the amazing title screen. Anyway, so that's the first thing, and then we've got some other options now. If I press the C key, we can change the color palette, and if I press the 3 key, we can turn the 3D off, and so we've got the black and white mode now. So those are the options we've got here, and we need to, of course, process all of that kind of thing. So what we've got here is we are processing the palette option, which is the C key, I believe, and so that's just toggling between the colors, and then we are reading in the 3 key, and here in each case we're having to send in the H register the key row of the keyboard we want to process, and then we're testing one of the bits of the H register that's returned to see if that key is pressed, and here we're just turning off or on the 3D there. So that's how we're doing that. Now, to start the game, we either press the fire button on the joystick or the mouse, which is processed by all the way up here. This read mouse routine will do that. The alternative is, of course, that we can start in hard mode. Now, hard mode is just very crude. We just start from level 128. The game goes up to 256 levels. So if you are feeling like a challenge, easy way to do it is just skip over to level 128. And the way we do this is we just set the accumulator to 128 and we jump down to an alternate start routine. And you can see the regular start routine sets the accumulator to 0 for level 0, and the hard routine starts at level 128, and so that's what we're doing there. So this is the main initialization for a new game. So we just start the song here for the main game. We reset the variables. It's always good to reset all of our data of variables to some known values or 0, depending on what we need. Here we're setting them to some initial values for a new level. And then we're initializing the objects on the screen with initial in its level. That's the sprites, the enemies, that kind of thing. Repainting the screen for the starting position and fading in. So we're ready for the main game loop, which is this show again routine. Now on the Spectrum Next, the reading of the mouse is done manually. It's not done as part of the interrupts. So we've got that there. We're then updating the sound sequence, which is done for the bleeping and blooping special effects, the simple special effect, which is the Chibi sound driver doing that. And then we are again processing various keys. So the first thing we're doing here is we're checking the P key. If the P key isn't pressed, we skip over the next bit. But if it is pressed, we do a short delay to wait for the key to be released. And then we pause for a while and we stop the music and we wait for it to be pressed again, and then we resume the game after a little delay once again. If we press the space key, we will reload the magazine. That's an alternate reload button. You can also use the right mouse if that's available. And then we've got some other options. We can press the S key, I believe it is, to change the cursor speed here. That's for the mouse, because the mouse might want to be fast, it might want to be slow. Again, we've got the palette change option here to toggle between the 3 types of 3D glasses. And we've got a 3D depth. Now on the title screen there was only an on or an off option because the title screen wasn't capable of changing to different stereoscopic depths because of the way it was drawn. It was basically a 16 color graphic, and we just disabled the right eye colors to make it into a 2D graphic. But the main game, we can actually change the depth, so there's 3 different depths and an off option for turning it off. Now, that's all of the key processing there. The next thing we're doing is we're updating the game ticks. Now, the game works with a 16-bit tick counter, which just constantly goes up, and certain events might happen every 16th tick, some might happen every tick, and some might happen every 256 ticks. So this is a way of slowing down different events in the game, like enemies getting closer to you and things like that. And it's an easy way of making the game harder in later levels. You just increase the number of ticks that the enemies move at. It makes the game faster. So that's how I'm doing that. What we do next is we update the sprites. We've got the sprite array, which points to all of the objects in the game, and the data count we're loading into the B register there. We process each sprite, updating them, moving them around and redrawing them if needed, moving to the next sprite after each one. Now, what we do need to do though to keep the cursor moving smoothly is we need to re-update the mouse cursor, check if the mouse keys have moved, and we need to show the new cursor position. And so that's what we're doing here, but we do that not every single sprite, we do it every few sprites to keep the game moving fast, but to get those sprites on the screen reasonably quickly. Next, what we're doing here is we are checking various events in the game. The first one is going to be the kind of gun we selected. The chibi gun, which is a parody of the minigun obviously, is an automatic weapon, so we can just hold down fire. Now, what we're doing here is we're checking the tick and seeing if we want to fire a bullet this tick. If we fired 2 bullets too fast, we'll run out of bullets. So we've got a good automatic speed here, but not too fast. We're then checking if the fire is held. That is set by the mouse reading routine. We're then checking the gun that's selected, and if the gun is number 3, then the chibi gun is selected. So that's what we're doing there. Then what we're doing here is we are checking if the right mouse button is pressed, fire 2, and if it is, we're reloading the magazine as an alternate way of reloading the magazine. Finally, we're checking fire 1 here, and we're firing a bullet here, which has got the wrong name. That should be no fire, not mo fire. A bit of a typo there. The letters look similar, and I didn't notice when I was doing the coding. Whoops. Anyway, finally here, we're just updating the cursor again, making sure that the mouse cursor is in the correct position, and we're repeating this whole loop. So that is the main loop. Now, the mouse routine is based on the one I covered in the platform-specific series. The platform-specific series example was actually the basis of this tutorial. Uses a 16-bit X and Y axis, and these are moved according to the mouse position. Now, with regard to the other systems, the keyboard and the joystick, and also the cursor joystick, which is effectively the keyboard, what I'm doing is I'm taking in the input from those, and I am simulating a mouse movement here. So we're using the cursor move speed, and we're converting these to an X and Y axis as if the mouse had been used. And then we're jumping past the hardware routine for reading in the mouse to this position do fake mouse here, and then using all of the rest of the mouse routines once we've converted the joystick input into an X and a Y movement relative to the previous position. This is, as I say, it's just basically to reduce the amount of code that needs rewriting for different pieces of hardware, because each of these systems took a long time to port to. It took 2 weeks per system, even though I did a fairly simple job of porting on all the systems. So yeah, just a simple way of cutting things down. Use most of the code from the mouse routine as possible to get the game working. And there we go. Now you can download the game from my website. You can also get the source code from the website, and as I always say, you can make use of the source code in any way you can. If you can make your own game out of it, then good luck to you. And as I say, you're welcome to do that. Do a commercial game with parts of my code. That's what it's there for. Have some fun with it, make something of it. If you want to support my making of games and my making of YouTube videos, you can buy my book. It's called Learn Multi-Platform Assembly with GB Akumas. Covers Z80 and a bunch of other systems you're probably not interested in, 6502, 68000, 86 and ARM. But if you are a big Z80 fan, it might raise some curiosity in you to have a look at the other ones, because I started off on the Z80 and I did find some interest in the other systems, so it's possibly worth a look. Anyway, if you've liked what you've seen, like and subscribe, because if you don't, then I might not make more games for this system, because it takes a lot of time making games for all these systems, and if people don't watch the videos, it probably suggests it's not worth my effort. Anyway, hope you've enjoyed this. Thanks for watching today, and goodbye.